So hello everyone, back again with me Sir Julius. We've already learned about positive and negative exponent. So for today we will learn about zero exponent and then fractional exponent. So without further ado, let us start our lesson today. So what will happen if the exponent is zero? So, to answer that question, we will try to find the pattern here. So, for example, I have 2 to the power of 4. We've already learned that 2 to the power of 4 equals to 16. So now we must try to find another way to get 16. But remember, it must be related to the question. 16 is equals to 32 divided by 2. 32 is equal to the power of 5. So we've got 16 as 2 to the power of 5 divided by 2. So now let us see the pattern in here. First, we can say that 2 to the power of 4 equals to 2 to the power of 5 divided by 2. It's the same, right? So now if I have 2 to the power of 3, 2 to the power of 3 equals to 8. 8 is equal to 2 to the power of 4 divided by 2. 2 to the power of 4 is 16. 16 divided by 2 equals to 8. Now if I have 2 to the power of 2 equals 4. 4 is equal to 8 divided by 2. So we've already seen the pattern here. Now if I have 2 to the power of 1. 2 to the power of 1 equals to 2 to the power of 2 divided by 2, or 4 divided by 2 equals to 2. So we can conclude that 2 to the power of 0 equals to 2 to the power of 1 equals to divided by 2. So we've got 2 divided by 2 equals to 1. So we can conclude that 2 to the power of 0 equals to 1. So in general, we can conclude that x to the power of 0 equals to 1. But it has one condition. X is not equal to 0. Okay, so for the next material we will learn today is fractional exponent. So fractional exponent will be related to radicals. So what is radicals? Radicals in bahasa Indonesia is called bilangan akar. So we can see in the picture, the number below radical symbol is radicand. And now we will try to learn how to read radicals. So, second root or square root, the index is 2. We usually don't write the index if it's 2. Meanwhile, if the index is 3, we call it third root or cube root. If the index is 4, we call it fourth root. And if the index is 5, we call it fifth root. So in general, we can say that fifth root of x, just like that. So now we will see about the fractional exponent. Now if I have square root of 9, 9 is equal to 3 times 3. So square root of 9 equals to 3. And then if I have third root of 64 or cube root of 64, 64 is 4 times 4 times 4, or 4 to the power of 3. So, the third root of 64 is equal to 4. So now we will see the same question in another line. So now if I have square root of 9, 9 is equal to 3 squared. So we can conclude that 3 to the power of 2 over 2. So the answer will be 3. It's the same with the example above. So now let's see third root of 64. 64 is equal to 2 to the power of 6. Let's see the pattern here. So the power in the radicand will be divided by index. So third root of 2 to the power of 6 equals to 2 to the power of 6 over 3. 6 over 3 is equal to, so we've got 2 squared equals to 4. So the example below will be the same with the example above. So we can conclude that cube root of a to the power of b equals to a to the power of b over q. But it has one condition. A does not equal to 0. So when we have fractional exponent, we can change it into its radical form. So now we will see the example. So for the first example, we must change the number, the radicals number, into fractional exponent. A, fifth root of 27, B, fourth root of p to the power of 3, and then C, a times third root of a to the power of 2. So for a, we can write it down just like what we've already learned from last slide. So when we have fifth root of 27, we must change the 27 first. 27 equals to 3 to the power of 3. So we can write it in fractional exponent 3 to the power of 3 over 5. Now for b, we've got fourth root of p to the power of 3. So it will be the same with p to the power of 3 over 4. Remember, the power of the radicand will be divided by index. Now for the last example, we've got a third root of a squared. So a to the power of 1 times a to the power of 2 over 3. So when we have the same base number, we can add the power. So 1 plus 2 over 3. So we've got a to the power of 1 2/3. So for our next example, we must change the fractional exponent into its radical form. So we have from a, b to the power of 1/2, and b, p to the power of 2 quarter. So now for a, we can separate it. B to the power of 1/2 equals to b to the power of 1 times b to the power of half. So b to the power of 1 equals to b. Meanwhile, b to the power of half will be b square root of b. Now for number b, p to the power of 2 quarter. So it will be the same. We must separate it first. So p to the power of 2 times p to the power of quarter or 3/4. So now it will be the same with p to the power of 2 or p squared times 4th root of p to the power of 3. So that's it for today. See you again next time. Bye.